In early 2024, a single electrical failure on a container ship and a bridge design from the 1970s triggered one of the most expensive bridge rebuilds in US history. Now the federal government is paying billions to replace a 2-mile crossing with something taller, longer, and built like a fortress. A new Francis Scott Key Bridge that will cost up to $5.2 billion, rise high enough for a 20-story building to pass beneath it, and defend itself with man-made islands designed to take the hit if a ship ever loses control again. This is the insane scale of America's new $5.2 billion Key Bridge, and why it has to be this extreme. To understand that, we have to look at what fell and how vulnerable it really was. When it opened in 1977, the Francis Scott Key Bridge completed Baltimore's outer beltway. It was a steel truss bridge almost 1.6 miles long, with a 1,200-foot main span stretching across the Patapsco River. Before the collapse, it carried around 40,000 vehicles a day. For almost 5 decades, it did its job without drawing much attention until March 26, 2024. That morning, the MV Dali, a fully loaded container ship, was leaving Baltimore Harbor. Then, without warning, it lost power. Investigators later found the cause to be a single loose wire. Not a major failure, not a complicated breakdown. One electrical connection shook loose while the ship was maneuvering. The vibration broke the circuit. The ship's electrical system shut down. Lights off, steering gone. At that point, the Dali was drifting at 8 knots with no way to stop. It struck Pier 17, and this exposed the bridge's biggest weakness. It was fracture critical, meaning if one main support failed, the entire structure could collapse. And it did within seconds. But there's another part of the story. The people responsible for the bridge had been warned about this exact vulnerability. Federal guidelines in 1991 recommended risk assessments for bridges like this. The same recommendation came again in 2009. Neither assessment was ever done. If they had been, the danger would have been impossible to ignore. By current standards, the Key Bridge was operating at a risk level roughly 30 times higher than what's acceptable for a major ship collision. So this wasn't just a ship losing power. It was a bridge designed in the 1970s facing ships that are far larger and heavier than anything its engineers ever planned for. And those ships aren't getting any smaller. The replacement for the Key Bridge isn't just a fix, it's an upgrade on almost every dimension. Taller, longer, and much harder to hit. Cargo was stacking up. The port was bleeding money, and every day counted. Within weeks, crews began removing the wreckage. By late spring, ships were moving again. But rebuilding the bridge itself was a completely different decision. The structure was nearly 50 years old. It had just shown how vulnerable it was. So instead of recreating the old design, officials chose to build something entirely new. A cable-stayed bridge with towers rising more than 600 feet and a main span of 1,665 feet, roughly 450 feet longer than before. Why go bigger? Because the old bridge forced ships through a tight opening, 1,200 feet wide and only 185 feet of clearance. In 1997, that worked because container ships were small. But by 2024, they were stacking containers 20 stories high. Many modern vessels need more than 190 feet of vertical room just to pass under a bridge. The new design raises the clearance to 230 feet, and it spreads the main supports far enough apart to create a navigation channel more than 1,000 feet wide. That space isn't just for size, it's for control when something goes wrong. But building a bridge that tall over deep water creates its own challenges. The foundations have to reach down through layers of mud and sediment that have settled for centuries. Right now, crews are running a test pile program. They're driving huge steel shafts into the riverbed and loading them with up to 10 million pounds to see how the ground responds. Those numbers decide how the real foundations get built and whether the towers can safely rise more than 600 feet above the water. That testing alone takes 6 to 8 weeks. The new bridge will still carry 4 lanes just like before, but with a big difference. The lanes will be wider and there will finally be real shoulders. On the old bridge, a broken down car blocked an entire lane. Now, drivers will have space to pull over. And then there's the defense system. How do you stop a 1,000-foot ship from taking out a bridge pier ever again? Each main tower will be surrounded by artificial islands built from rock, concrete and fill. If a ship loses control, it hits the island instead of the bridge. The sloped sides force the hull to ride up and run aground before it ever reaches the tower. On top of that, 6 enormous dolphins will sit around the navigation channel. They're standalone structures designed to absorb the impact of a fully loaded container ship. If a ship hits one, the dolphin takes the blow and the bridge survives. This protection system is a major reason the cost keeps rising. You're not just building a bridge, you're building a shield around it. As for the old bridge, most of it was removed when the channel was cleared, the steel truss is being cut into sections, shipped to permitted facilities, and recycled as scrap metal rather than just dumped. On site, about 10,000 tons of concrete from the old deck has been stockpiled and is being crushed for reuse on the project. Things like temporary haul roads and staging areas. Some of the old approaches may still be reused, but the main span is gone, and rebuilding the original design was never really on the table. That idea disappeared the moment the bridge fell. The problem is, building a bridge this tall, this protected, and this future-proof doesn't just change the skyline over Baltimore, it completely changes the price. So now the question is, how does a bridge project jump from under $2 billion to more than $5 billion in less than 2 years without adding any extra lanes? Back in April 2024, early rough estimates put the cost between $1.7 and $1.9 billion. By November 2025, that number had climbed to between $4.3 and $5.2 billion. And this is pretty normal when rough sketches turn into real engineering. Here are the 4 factors where the budget is going. First, the bridge itself. A cable-stayed span that stretches 1,665 feet needs huge amounts of material. High-strength steel for the cables, reinforced concrete for the towers, and deep foundations to hold everything up. And long spans don't scale simply. Every extra foot adds more complexity, more weight, and more cost. Then comes the protection system. The artificial islands and the massive dolphins are a project of their own. They require millions of cubic yards of rock and fill, all built in the middle of an active shipping channel. And because these structures permanently reshape the riverbed, every step comes with strict environmental rules. This defensive system is one of the biggest drivers behind the doubled budget. Inflation plays a major role too. The Federal Highway Administration reports a 72% increase in highway construction costs over the past 5 years. Steel, concrete, heavy machinery, skilled labor, everything is more expensive. And with the bridge scheduled to open in 2030, every contract has to include future cost increases as well. There's also the speed premium. Normally, a project of this scale would spend years in planning and environmental review. This one couldn't wait. Design work and construction are happening at the same time. That speeds up the schedule, but it increases risk, and contractors charge more to take that on. So how does $5.2 billion compare? For reference, the eastern span of the San Francisco-Oakland Bay Bridge cost about $6.5 billion, and that was over a decade ago. Measured per mile, the new Key Bridge sits alongside some of the most expensive bridge builds in U.S. history. Not the single most expensive, but absolutely in the top tier. In other words, this isn't a routine replacement. It's in the same spending league as the headline megabridges you've seen on the news. So is 6 years actually fast for rebuilding a bridge like this? The new Key Bridge is expected to open in late 2030, about 6 years from collapse to completion. Globally, that may not sound fast, but for American infrastructure, it is. It is because in the US, major bridges normally spend years, sometimes nearly a decade in design work, environmental review, and public meetings before any construction begins. The Key Bridge didn't follow that playbook. Design work started almost immediately after the collapse. Permits were pushed through quickly, and the project is using a delivery method called progressive design build, which lets contractors start early work while the final design is still being finalized. That overlap saves years. But it doesn't remove the realities of building something this large over water. Foundation work is set to begin in Q2 or 3 of 2026. After that comes the towers, then the cables, then the deck. Each step relies on the last, and marine construction leaves no room for shortcuts. Storms, tides, equipment moves, and narrow work windows all slow progress. So what will drivers see when the bridge opens? Still 4 lanes, but the experience will feel different. Wider lanes, real shoulders, better visibility. For truckers heading to the port, it's the same route they've always taken, but for the port itself, this clearance upgrade is enormous. A 230-foot vertical clearance isn't just for ships today. It's built for ships that don't exist yet. The global fleet keeps growing. 20 years from now, vessels entering Baltimore will be larger than anything the old bridge could have handled. This new one is designed to stay ahead of that curve. It's true that some countries build faster. China, for example, has delivered similar scale bridges in equal or even shorter timeframes, but they operate under a different model. There's less regulatory oversight, centralized authority, and quicker land approvals. The US trades speed for more review, more process, and more environmental protection. The design of the Key Bridge does help with speed, though. Cable-stayed bridges need fewer piers in the water, which means fewer deep foundations, the slowest part of any marine project. And that fortress protection system helps too. By placing the main supports outside the navigation channel, workers don't have to shut down ship traffic every time they build a pier. Even with all these efficiencies, finishing a project of this scale in 6 years is considered a sprint in the world of infrastructure. Before we finish, there's something we can't skip. The people who were on the bridge that night. 6 construction workers were out there doing overnight maintenance when the ship lost control. They never had the chance to get off the span. Their families are still living with that loss. Memorials line the waterfront, and the final design for the new Key Bridge includes a permanent memorial to honor them. This new bridge is meant to make a disaster like that much harder to repeat. Stronger wind standards mean the towers and deck are designed to handle hurricane-level gusts. A higher deck helps protect against storm surge. And even though Baltimore isn't a major earthquake zone, the structure is still being designed to meet modern seismic requirements, on top of a pier protection system that simply didn't exist before. So what does this bridge say about the future of American infrastructure? This isn't a 50-year bridge. It's a roughly 100-year bridge. It's built for ships that don't exist yet, and it's designed to survive situations we hope we never see. A disaster in 2024 forced America to rebuild the Key Bridge. The replacement is a fortress, intended to make sure the same kind of failure is far harder to pull off a second time. So the real question is this. Is this level of engineering worth $5.2 billion? Or would you rather see more bridges built faster and cheaper, even if they're not this overprotected? Thank you for watching. And if you like it, make sure to subscribe and hit that notification button so you don't miss our next mega build story.